A very good day. Today I will be presenting my research proposal, which is a 2D nanomaterial-based colorimetric aptasensor in heavy metal detection in environmental forensics. A review. This review focuses on how 2D nanomaterials can improve rapid, selective, and field-ready detection of heavy metals in environmental samples. Heavy metal contamination in soil and water remains a major environmental problem, especially lead mercury, cadmium, arsenic, and chromium ions. Traditional methods like AAS, ACP, AES, and ACP-MS are accurate, but they are very expensive, time-consuming, and depends on laboratory facilities. Because environmental forensics often needs fast on-site decisions, a simpler detection method is needed. Let's look at aptasensors. Aptasensors uses aptamers, which are short DNA or RNA molecules selected by selects to bind specific targets. They are stable, selective, and easier to modify than antibodies. In this topic, 2D nanomaterials such as graphene oxide, vaccines, and TMDCs are important because they can work as nanozymes and produce visible color changes to reactions such as TMB and hydrogen peroxide. Many current colorimetric sensors still rely on gold nanoparticles, which can be costly and less stable in complex samples. In addition, a lot of studies are still done under clean laboratory conditions instead of real environmental samples. This makes it very difficult to judge how well the sensors will perform in actual forensic cases. This review has two main objectives. First, First, it aims to summarize the recent application of 2D nanozyme-based colorimetric sensors for detecting heavy metal ions. Second, it aims to assess the technical barriers and future prospects of using these sensors in environmental forensics. The review assumes that 2D nanomaterial-based colorimetric sensors can detect heavy metals with good sensitivity and selectivity. It also assumes that their main value lies in combining aptamer recognition with nanozyme catalysis for faster and more practical decision. However, their performance may still depend on how well they work in real environmental samples. The literature already shows that 2D nanomaterial-based colorimetric sensors are effective for heavy metal detection. It highlights real water and soil testing, cross interference, long term stability, and portable readouts such as smartphone colorimetry and color charts. The goal is to move from laboratory detection to practical environmental forensic evidence. The literature The literature shows promising results for several metals. A GO-based system works for lead ions. Reduced GO works for mercury ions. And MXene-based systems are effective for cadmium ions. WS2 nanosheets are useful for copper ions. Graphene aptamer hybrids can detect arsenic ions. GO peptide nanozymes can detect chromium ions. While graphene and MXene hybrids can detect lead and mercury ions together, most of the systems achieve low nanomolar detection limits and very good selectivity. A narrative literature review was suggested by defining the scope, searching and screening relevant studies, extracting key data, grouping grouping findings thematically, comparing sensor performance, assessing limitations, and synthesizing the evidence for environmental forensic applications. In conclusion, 2D nanomaterial-based colorimetric sensors are a promising solution for rapid and sensitive heavy metal detection. Their real value depends on how well they perform in complex environmental samples, not only under ideal lab conditions. Thank you very much.